We have the new CFE Higher Maths Block 1 revision, basically the practice unit assessment or the practice NAB. This is based on a course following straight line differentiation, sets and functions, and recurrence relations for Block 1. Other schools may be doing it differently. The revision questions are available on the Wade Maths website under Higher Unit Assessments. So we're going over Block 1 Revision A. So have a good look at this bit at the top of the questions. It tells you which sub-skill is being tested each time. And those are the sub-skills that will be tested in the assessment, obviously. Question number 1. A straight line has the equation x plus 2y plus 3 equals 0. Find the point of the line perpendicular to the given line, which passes through the point -3, 6. So we need to know the gradient of the original line. To get the gradient of the original line, we need to put it into the form y equals mx plus c. So we rearrange to make 2y the subject. We then make y the subject by dividing through by 2. So the gradient of the original line is -1/2. So the gradient of the perpendicular line will be 2 because we know the product of a line and of the gradient of a line and the gradient of a line perpendicular to that is always -1. So the perpendicular line is 2 because 2 times -1/2 is -1. We also have the point -3, 6. So we'll just substitute the values into the equation of a straight line. So y minus 6 is 2x minus -3. And then we can just expand the bracket and put it into that format. On to number 2. ABCD is a rhombus. A rhombus has parallel sides. I've marked that on. We need to be aware of that fact to do the question. Side AD has equation y equals 5x plus 2 and point C has coordinates 3, -2. Note that the diagram is not to scale. Find the equation of the side BC. So the gradient of BC will be 5 because the gradient of AD is 5. It is in the format y equals mx plus c there, so the gradient will be 5. We have a point on the line, substitute into y minus b equals mx minus a. And that's us. Nice easy question, 2 marks. Right, question 3, reasonably tricky. Calculate the size of the angle between these two lines. Now this line, I know has a gradient of -2 and a y-intercept of -1, so that's the blue line there. It's going to look something like that. Y equals 1/3 x plus 2, a gradient of 1/3, a y-intercept of 2. So I'll mark that with a red line here. So we are looking for this angle. We can move the red line down to here and the blue line across to the right a little bit. And the angle between those lines will not change, so we could redraw it like that. So if I can find this angle, which is the angle between the positive direction of the x-axis and this line. And I could also find this angle. Then it'll be straightforward to find out the angle in between them. It'll just be the green angle, subtract the purple angle if you like. So to get this angle here, we're going to use the fact that m equals tan of theta, or tan of the angle between the line and the positive direction of the x-axis. So we have a gradient of -2, so tan theta equals -2. A little bit of ASTC practice here. So we ignore the negative sign. We do tan to the -1 of 2, which is 63.4 degrees. But we are looking in the quadrant where tan is negative, which is the second quadrant between 90 and 180. Only sine is positive in this quadrant, so tangent is negative. So we do 180 minus 63.4 degrees, which is 116.6. So this angle here is 116.6 degrees. Now for the purple angle, we know the gradient is 1/3, so tan of that purple angle is 1/3. So the angle itself would be tan to the -1 of 1/3, which is 18.4 degrees. So the angle between those two lines will be 116.6 subtract 18.4, which is 98.2 degrees. If you were thinking, why are we not looking in this quadrant? If we're looking in that quadrant, we would be looking at not just that angle, but also be extending it round all the way to there. But we're not interested in that interpretation, or not interested in that solution in the context of this question. We know we want this first angle, the first green angle and the purple angle. Question number 4. Health and safety regulations state that to safely use ladders, the gradient of the ladder should be between 3.6 and 3.8. Explain if the ladder shown below is safe to use. Again, it's just m equals tan theta. So if we do tan of 105, we get a gradient of -3.73. Now we just need to interpret our result in the context of the question here. This gradient, in terms of it being a ladder line against the wall, would just be the same gradient if we just kind of flipped it. Imagine it's lying at the same angle but towards another wall like this. So this would give the positive gradient of this -3.73. So interpreting the question in context, the gradient's 3.73. So the ladder is safe as the gradient of 3.73 is between 3.6 and 3.8. Notice we have a hashtag here, so we must make that statement, and it must make sense. The diagram shows a graph of y equals f of x, gives us the maximum turning point and the minimum turning point, i.e. this point here, this point down here. Sketch the graph of y equals f of bracket x minus 3 bracket plus 2. So we should know, if we have revised, or if we understood the first time and there was no need to revise, that this moves the original graph 3 to the right, and the plus 2 on the end moves the graph 2 up. So our -3, 3 along 2 up, will now pass through 0, 2. Our maximum turning point, -116, will move 3 along, which goes to 2 along and 2 up, so 16 up to 18 up. Our minimum turning point of 3 over 2, or 1.5, comma -2, moves 3 along, so I'll go to 4.5, or 9 over 2, because we do like top-heavy fractions in higher maths, and it will move up from -2 to 0. So it'll actually be an x-intercept or a root. So we need to keep the shape the same. We're not changing the shape, we're literally moving it along to the right and up. And we've annotated the point. So if it's an intercept, we don't need to write 0, 2 here because we know it's crossing the y-axis. And here, because it's touching the x-axis, we can just write 9 over 2. We don't need to write the y-coordinate. Number 6. This is basically not a very good question unless I'm totally misinterpreting the way to do it for EF 1.3, which is expressions and functions 1.3. This is all about transformation of graphs, moving graphs left and right and up and down. We do have some information here, so I'll talk through the solution. I'm going to substitute in the values that I know. So if I substitute in x equals 0 and y equals 2 into here, I get 2 equals a to the power b. I'm also going to substitute in 3, 16. So 16 equals a to the 3 plus b. Using our National 5 knowledge, I know a to the 3 plus b is the same as a to the 3 times a to the b. So I have these two equations. I'm going to try and solve them. Well, I do know this here is 2. So I'm going to substitute that in here to make it 2 times a cubed. So substituting 1 into 2. Again, I know a to the b is 2, so if I've got a to the b here, I can just replace it with 2. I can just substitute in 2. So 16 equals 2a cubed. So a cubed will be 8. A will be the cube root of 8, which is 2. So I've got a. Now put in the value of a into equation 1. 2 equals 2 to the b, so b is 1. So a equals 2, b equals 1. Question 7. So a little bit messy up here, but the 3 at the front, thinking of 3f of x, this 3 will stretch the graph vertically. So rather than having a maximum value of 1 and a minimum value of -1, it will be 3 and -3. Cos of x minus pi by 6, thinking of it as f of x minus pi by 6 moves the whole graph, the whole cosine curve along to the right by pi by 6, or if you like thinking in degrees, 30 degrees. So I have decided that it's going to start at pi by 6. I have then just drawn a cosine curve. I know the length of that cosine curve is 2 pi radians, or 360 degrees. So I've drawn that bit in. Then, after I've done that, I've just extended back. I know this has to cross the y-axis as well, because I'm told to look between 0 and 2 pi, or between 0 and 360 degrees. So I cannot leave this bit blank. The cosine curve normally crosses at 90, but it's been moved along by 30, so this point here will be 120 degrees. Now 120 degrees, well, I know 60 degrees is pi by 3 radians, so 120 degrees will be twice as much, so that will be 2 pi by 3. The minimum value normally occurs when x is 180 degrees, or pi radians. But it's been moved along by 30 degrees, or moved along by pi by 6 radians, so this will be 210 degrees, or pi plus pi by 6, so a whole pi at a sixth of pi, so that will be 7/6 of pi radians. Or an alternative way to think about it, it should be 210 degrees. Well, if 30 degrees is pi by 6 radians, 210 degrees is 7 lots of 30 degrees, or 7 lots of pi by 6. 7 pi by 6. This x-intercept here should occur at 270 degrees. It's been moved along by 30 degrees, so that'll be 300 degrees, or 5 lots of 60. 300 is 5 lots of 60, or 5 pi by 3 radians. And because we're asked to go between 0 and 2 pi, I've clearly marked that on the graph. Notice that this point here is at the same height as this point here. That's important because it has a wavelength of 360 degrees, or 2 pi radians. So just make sure all of your points are annotated. That is very important. Do not miss any out. The diagram below shows a graph of y equals a sin bx plus c. So the value of a will either stretch or reflect the graph of sin x. The value of b will either compress horizontally or stretch horizontally the graph of sin x, and the plus c on the end will move the graph of sin x up or down. Now looking at this, the overall height is still 2. Normally it's from -1 to 1, which is an overall height of 2, or an amplitude of 1, we would say. That is still the same. But the graph has been basically flipped upside down. So after B and C have occurred, it's been reflected in the x-axis. So as it's been flipped upside down, essentially, the value of A is -1. Right, remember, pi radians is 180 degrees. And the length of the sine curve should be 360 degrees. So this curve has been compressed by a factor of 2. So B is 2. And our center line, if you'd like to call it the center line, which normally comes through here, that is normally the x-axis, but the whole graph has clearly been moved up by 1, so C is 1 because the whole curve has been moved up by 1. Question number 9. A third function is defined as h of x equals g of f of x. Find an expression for h of x. So h of x is g of f. Right, what is f of x? F of x is 2x plus 1. So let's replace f of x here with 2x plus 1. So I'm now going to try and do g of 2x plus 1. So g of whatever is in the bracket. The rule for g says 1 over 3 times what is in the bracket. So it'll be 1 over 3 times 2x plus 1. And that is g of f of x. So basically replace the x with whatever is in the bracket. So the x on the denominator here becomes 3 bracket 2x plus 1. Explain why x equals -1/2 cannot be a member of the domain of h of x. A couple ways of doing this. We can substitute this in, and we'll find out that we end up with 1 over 0. We cannot divide by 0. Alternatively, state we can't divide by 0. Then say that the denominator cannot equal 0. Expand the bracket, make 6x the subject, then make x the subject. Then make the statement, therefore x equals -1/2 is not in the domain. Again, that is because we cannot divide by 0. Another commonly recurring question in higher maths is trying to square root a negative number. We also can't do that. So just beware that squaring a negative number and dividing by 0 quite often is related to the domain questions. Questions about what can and cannot be in the domain. Number 10, find the inverse function f to the -1 of x. A couple different ways of teaching this. Essentially, if we swap the x and the y's, so rather than y equals 4x plus 3, we have x equals 4y plus 3, and just rearrange to get this in terms of y. So make 4y the subject, then make y the subject, and this here, okay. This term here will be the inverse of the original function. So the inverse function is x minus 3 all over 4. Remember, the inverse function essentially undoes f of x. So here, f of x says take x, multiply it by 4, and add on 3. The inverse function is saying take x, take what you have, subtract 3, divide by 4. Now we know from S1, maybe even primary 7, if we multiply by 4 and add 3, to undo that, we subtract 3, then divide by 4, so we can be confident that we have this correct. Question number 11. Question number 11. A sequence is defined by this recurrence relation, and we are giving 3 values in the recurrence relation. So basically the next term in the sequence is m multiplied by the previous term plus c. So if I take u5 and u4, I can substitute them into this original recurrence relation. So u5 is 3, u4 is 4, so I get an equation. And because u5 and u6 are also consecutive terms, I can substitute those into the original recurrence relation as well. And I have 1 equals 3m plus c. Once I have done that, we have two equations in M and C, so we can solve those simultaneously. We already have the same coefficient of C, so I can just do equation 1 subtract equation 2, which results in the solution M equals 2. I can then take that and substitute into equation 1 or equation 2. Because it's reasonably straightforward, we can just do this in our head. There's no great need to show the workings, it's so straightforward. So 4 2's add something equals 3. The something must be -5, so we can just make that statement. And then we're taking the value of M and the value of C and just rewriting the original recurrence relation. And then the second part, find the recurrence relation described by the sequence and use it to find the value of U3. Well, actually, I've already done this bit. So use it to find U3. Well, U3 is related to U4 and U2. I don't know what U2 is, but I do know what U4 is. So I can use the fact that U4 will be 2U3 minus 5. So we don't actually need that to be there, because we know the values of M and C, so there's no need for that line. So substituting in, then we can rearrange this equation. So make 2U3 the subject, then make 2 the subject. So U3 will be 9/2. And again, we like top-heavy fractions at higher, so I'm not going to write 4.5. Question number 12, the owners of an orchard start to harvest the crop when 5 tons of apples were ready to be picked, blah, 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 blah. Part A, set up a recurrence relation. Well, 90% of the crop will be picked. That will leave 10% of the crop. And between each weekly harvest, another 3.5 tons of apples will be ready to be picked. So basically next week, we have 10% of what we had last week and another 3.5 tons. Obviously at harvest time, apples are still growing, just in the context of the question there. So there's our recurrence relation. At the end of the season, the owners aim to harvest all apples. Is the expectation that the final harvest will be over 4 tons correct? Well, let's look at the long-term limit of this. So we have our values of A and B. We have our limit formula. The limit is B over 1 minus A. So just substituting in, we have 3.89 tons. It says explain your answer. As the limit, 3.89 tons, is less than the expected harvest, 4 tons, the expectation is incorrect. It's not as high as they thought, basically. Relate it to the question. Explain your answer. You've got to write something down. Don't just say yes or no, that's not an explanation. Question number 13. Find f dashed of x given f of x. Before we differentiate, we must have it in index form, and we must have all powers of x on the top of the fraction, not on the bottom of the fraction. So our 1 over x to the 5 comes up, it becomes x to the -5. 2 lots of the cube root of x squared. Well, the top number is the power, the bottom number is the root, so that is 2 lots of x to the 2/3. Then to differentiate, power to the front, reduce the power by 1. So 1 mark for getting that bit. And power to the front, so 2 times 2/3 is very unsurprisingly 4/3. And 2/3 subtract 1 whole, 2/3 subtract 3/3 is -1/3. Second mark for that. As we started in this format, we should really put it back into that format. Again, in your test, you get your marks for doing that, but let's just practice doing it as well. Let's practice changing from negative powers to positive powers. There's absolutely no harm at all. If you do this bit incorrectly, you will not lose marks. Oh, that bit shouldn't be there. Right, f of x is given by this. Evaluate f dashed of 5. Let's differentiate. So 5x differentiates to 5. 2x squared, 2 to the front, reduce the power by 1 is 4x. Differentiate -3rd x cubed. Power to the front, 3 times a third is 1 whole. Reduce the power by 1, x squared. We are evaluating f dash to 5, so substitute in 5, and we get 0. Part B, explain your answer in relation to the coordinate axes. When we find f dashed, we are finding either the rate of change, or the derivative, or the gradient of a function at a certain point. Because we're relating it to the coordinate axes, so it's basically saying it's a graphing question. If the gradient's 0 at this point, the tangent to the curve at that point will also have a gradient of 0. Relating that to the coordinate axes, it will be parallel to the x-axis. So as the gradient at x equals 5, as the gradient equals 0, x equals 5, the tangent at x equals 5 is parallel to the x-axis, because we're relating it to the coordinate axes. Question 15. A curve has equation y equals x cubed plus 4x plus 1. Find the equation of the tangent to the curve at x equals -2. So just a little sketch what we're actually trying to find out. The sketch might not be overly accurate, but basically we have a curve. It's a cubic, so I know it's going to look something like that. The equation of the tangent at x equals -2. So when x is -2, the tangent to the curve is what we've been asked to find out. So we're essentially being asked for the equation of a straight line. To find the equation of a straight line, we need the gradient, and we need a point on the line. So let's find the gradient first. To find the gradient, we differentiate and substitute in the x coordinate. So that will result in a gradient of 16. I have the x coordinate, I do not have the y coordinate. How do I find the y coordinate? Well, y equals this. It's basically shorthand for the y coordinate. It's the x coordinate cubed plus 4 times the x coordinate. So if I want the y coordinate, substitute in the x coordinate. And that gives us a y coordinate of -15. I have the gradient. I have the x and y coordinate of a point on the line. Substitute into y minus b equals mx minus a. There we go. Where would the marks come from? Differentiate, gradient, find the y coordinate, substitute into there. Again, no harm in practicing multiplying this out and rearranging, because in the final exam, the chances are you will have to. Last question. Surface area of an open box with a square base can be represented by this formula. Find the value of x which minimizes the surface area of the box. Very important words. Minimizes. It's an optimization question. In an optimization question, we need to differentiate. We need to set it equal to 0, because for a minimum or a maximum value, the differential or the derivative is 0. We then solve the equation that we're left with to find the value of x. So let's do that. Before we differentiate, again, we can't have 54 over x, so we'll bring the x up, so it becomes x squared plus 54x to the power -1. We differentiate, power to the front, reduce the power by 1. Make our statement, very important we make the statement. Set the derivative equal to 0. If we don't set this equal to 0, we will not get a mark for doing so. We then solve. At this point, I could quite easily multiply every single term by x squared. 2x times x squared would be 2x cubed. 54 over x squared multiplied by x squared would be 54. 0 times x squared would be 0. Alternatively, we could bring the -54 over x squared across to make 2x the subject. Then we can multiply both sides by x squared, which essentially takes this term up to here and multiplies it by the 2x. Either way of those two methods I've just described will result in 2x cubed equals 54, which in turn means that 1x cubed, or x cubed, equals 27. Cube root of 27 is 3. I need to show it's a minimum. I can't just assume it's a minimum. I need to justify that. So nature table, so we'll have the value of x. So I need to look just before and just after x. I have a dashed of x, the differential of a. So picking a number just before 3 is 2. 2 2's are 4 minus 54 over 2 squared. Well, 54 divided by 4 is 10. Well, it's not 10, it's more than 10. So we've essentially got 4 take away more than 10. It's going to be a negative value. I don't need to work out the actual value, I just need to know if it's positive or negative. For substituting 3, 2 3's are 6. 54 over 3 squared is 54 over 9, which is also 6. 6 take 6 is 0. After 3, I've got 4, or 5, or 6, or 7, or 8. Any value after 3, I'm going to pick 10. I could pick 4. I'd expect most of you guys to pick 4. But by picking 10, I've got 2 10s are 20. 54 over 10 squared is 54 over 100. That's not even a whole. So I've got 20 take away something quite small. I know that's positive. Showing the slope. That's definitely a minimum. Find the value of x which minimizes the surface area of the box. We'll also need to make the statement x equals 3 gives the minimum surface area of the box. And that is the end of it.